high pressure at the poles, right? Why? Because it's cold, right? So we get high pressure that forms over the North Pole and high pressure that forms over the South Pole. At the equator, the weather's warmer, so we end up with low pressure. Okay, heated air expands, becomes less dense. Because it's less dense, the molecules can move around each other, and they don't touch each other, so they don't put any pressure on one another. Good so far? Okay. Now, we talked yesterday, wind typically moves from areas of high pressure to low pressure. High pressure to low pressure. So at the North Pole, we get a current that blows southward. Now, this is a two-dimensional diagram, and it's very difficult to draw three-dimensional wind currents, so you're just going to have to make the best of it with your imagination. So this wind starts to blow southward. Now, the problem is it never reaches the equator. It heats up too quickly, approximately at 60 degrees north latitude. What happens when things are heated? They expand, become less dense, and they rise off the surface of the Earth. More air comes in to replace them. And this air cycles back and creates a convection current here. The exact same thing happens at the South Pole. The wind starts to blow this direction now, because we're going from high to low, so it blows northward. But it heats up at 60 degrees south, rises off the Earth, cycles back, forms a convection current. Question so far?
But wouldn't that occur like everywhere else too? Like in between like the
We're getting there.
Zero?
Yes. Okay, now, here, from 30 degrees north, this air is cooler than this air, correct?
Yeah.
So this cool air has high pressure, this warm air has low pressure. So we get a current that starts to flow towards the equator. It gets very hot very quickly at the equator, and it rises at the equator. Connor, you can sit at the desk over there. Because you're blocking. Okay. Now, this air does the same thing. More air replaces it, forces this air up, this air cycles back, and we get another convection current forming. Same thing happens in the southern hemisphere. We get this cool air flowing towards the equator, it gets very, very heated, rises off the Earth, convects back, and we have convection current forms there. Do you notice how everything is mirroring itself?
Yeah, pretty much.
Okay, and it should. The northern hemisphere is going to mirror the southern hemisphere. Okay, now, something interesting happens, except for the really poorly drawn lines, right? Something interesting happens in between here. All right? See this air being pulled off the Earth here, and this air being pulled towards the Earth here? That pulls air with it, towards the Earth here, and away from the Earth here.
Okay.
Okay? Yes, sir?
When that air gets stuck in convection.
Absolutely. Now, this air also gets stuck in a convection current, just like Connor said. Because this air is being pulled down, it replaces the air that's being pulled up, and the air that's being pulled up replaces the air that's being pulled down, and we end up with another convection current in between these two. So this green convection current here was actually created because of this one and this one. The same thing happens in the southern hemisphere. Air gets sucked down towards Earth here. It gets pulled away from Earth here. This air replaces this air. This air replaces this air, and we have another convection current.
This is so weird.
But it makes sense, right?
Yeah, a little
It's
bit.
all because of the differences in temperature and the differences in air pressure on a global scale. Okay? Earth is very complicated.
Why can't you just make it like...
Now, what ends up happening then is we get distinct patterns of wind. Okay? Let's talk about the north first. Up here, our winds blow from the north southward, correct? All right? But, so they're supposed to go that way. They're supposed to go straight south. Coriolis effect says that winds in the northern hemisphere turn to the right. So instead of this wind blowing straight south, it's going to turn to the right. Now, a wind blowing this direction, pretend you're in a car and you're traveling this way. If you were to turn right, you would turn this way, right?
Yeah.
Does that make sense? Okay. To us, looking at this diagram, it should go that way. But the wind isn't traveling that way. The wind is traveling south. It gets turned to the right. Imagine you're going down. Turn to the right. It actually goes this way, right? So our wind up here starts to turn this way. Now this is moving from the east to the west. So it's going to be called an east wind. In fact, we're going to call it the polar easterlies. The polar easterlies. And we call it the polar easterlies, well, for two reasons. It's around the pole, and it's moving east, from the east. Right? Polar easterlies. We name the wind by where they come from. It's coming from the east. It's around the pole, hence polar easterlies.
Would the one at the bottom be the western?
Watch.
Or the
Now watch what happens. This is really cool. These winds have high pressure here, low pressure here, so they blow northward, right? But they also turn to the right. To the right.
Hold on, wait. But they're supposed to turn
Oh, I'm sorry, to the left. Thank you. Southern hemisphere winds turn to the left. I wonder why that looks so funny. Okay. In the southern hemisphere, because of the Coriolis effect, our winds turn to the left. So we end up with winds that are blowing from the east to the west again. So we can also call these polar easterlies. Right. Happy Easterlies.
Happy Easter early.
Okay. Here, from the equator to about 30 degrees north, we have winds that are blowing towards the equator. They're blowing south, right? Winds that blow down turn to the right, so they end up moving this way. Okay, and these get a name called the trade winds. And I'm sure you talked a little bit, hopefully, about the trade winds with Mr. Stanley last year, yes?
No.
No? All right. Trade winds were really important for, believe it or not, trade. When they used to use big sailing ships for trading things. These were very helpful for sailors in Europe to get to South America and to get to the West Indies, which we know as like the Bahamas and Cuba and places like that.
We talked about this with Mr. Stanley.
A little bit? Okay, good. So these are called the trade winds. Again, because they were important in trade. They come from the east and go to the west. Okay, so they're an easterly wind. Now the same effect happens here, but these winds blow northward. They turn to the left because they're in the southern hemisphere. Again, look how it's mirroring each other. And we also call these trade winds. Questions so far? Yes, sir.
Were we going to talk about seasons today?
If we have time. Now, something interesting happens then in these mid-latitudes. We are in the mid-latitudes. We're at approximately 41 degrees north. You'll see this is from 30 to 60. So we're in this region. Most of the United States is. These winds blow, if you look at this convection current, they blow northward. They turn to the right. So these go from the west to the east. So we don't call these easterlies, we call these westerlies. So these are going to be called in the northern hemisphere and in the southern hemisphere, the prevailing westerlies. What does prevailing mean? What does prevailing mean? To prevail means to take over, to win. All right, so these are the winds that take over in this region, and they're west winds, so we call them westerlies. Make sense? These are very important winds, and we'll talk about that in a second.
No, I don't get it.
Okay, prevailing means to take over,
Yeah, I know that.
to win something. They're coming from the west
Oh.
and traveling this way.
Why?
So these west winds take over this region and move everything this way. So they call them prevailing westerlies. Yes,
So
ma'am.
is that where we get our low starts from the west?
Absolutely. This is why the weather in the United States moves from the west to the east, generally.
Why are the other ones going east and that one going west?
Because of the way the convection currents form. All right, the convection currents generally blow from the wind from north to south in the northern hemisphere. But the way that this one and this one forms, it forms a different current in between that cycles in the opposite direction.
Oh, okay.
So see, this one's cycling counterclockwise, this one's cycling counterclockwise, this one's cycling clockwise. So it all has to do with how the convection currents form on Earth's surface. And because of that, the winds turn different directions because of the Coriolis effect. Okay, does that make sense? It is a little strange, but it does make sense when you actually slow down and think about it. Okay, the same thing happens in the south. In these mid-latitudes, the wind now is blowing south according to this convection current. Winds turn to the left. And these are also called prevailing westerlies. Or sometimes they just consider them westerlies. It's really up to you what you call them. I'm just going to write westerlies in this one. Now, these don't get a lot of action in the south because there's really not much in the southern hemisphere. Okay, between Antarctica here, there's really only a couple of things here. Australia, the tip of South America, the tip of Africa. There's really not a lot of land in the southern hemisphere anyway, so people don't usually worry about these as much. Okay, questions so far? How you holding up? It's a long time to hold that, I know, I'm sorry. Okay, now, something interesting happens here at the equator. Do you see how the air convects this way, and then it convects this way, and it leaves this space in the middle where nothing's happening?
Yeah.
The wind doesn't go across the equator very often. It's like a blank spot. So what happens is we end up with no wind there. Sailors used to get stuck here in their ships. They couldn't go anywhere because there was no wind. And they said, oh man, we're really in the doldrums now. So they ended up calling this area of the world the doldrums. Okay, which is not a wind belt, it's just a nickname for that area of the globe where you get no wind. Okay, this 30 degrees north here, a lot of trade happened here, right?
Yeah.
Sometimes boats would get stuck here. That's a really terrible drawn boat. Boats would get stuck right at these mid-latitudes, about 30 degrees north. Why? There's no wind, because look, we've got wind blowing this way and wind blowing this way, but nothing happening here. See, the same thing happened here, happens here, just in the opposite direction. So at this mid-latitude, we don't get any wind. And boats used to get stuck there for days and weeks and months on end, and so they'd start running out of food. All right, so in order to save food and try to get a little weight off the boat so they could hopefully move a little easier, they would dump their horses overboard. So these ended up being called the horse latitudes.
Why did they do food named horses?
Okay, these were called the horse latitudes. A lot of these, especially English traders, they would have a lot of horses because they would take horses and sell them to other places in the world, and they would have lots of horses on board that would have to eat every day. And so to save food, they would just throw the horses over and eat the food themselves.
Why don't they just kill one?
Okay, because they weren't expecting to get stuck.
Yeah, Connor has a point.
Yeah.
That's a good point. I don't know.
And then, like, just
Alright.
eat it all.
Now, something else really cool happens up north that really drives our weather. Okay? This polar wind, this polar easterly wind, and this prevailing westerly wind are very different temperatures. Okay? Very different temperatures. This is very, very cold, and this is usually a little bit warmer, quite a bit warmer actually. And we end up with something in between there that's not really following the straight path anymore. It's called the polar front. And we'll talk about more of that in a moment. But what happens is this very cold air, very high pressure air, and this lower pressure air, they meet each other. And where they meet each other, the high pressure air wants to try to get to the low pressure air, which creates what? A wind. A very powerful wind that moves from the west to the east across in this different pattern all the time, this kind of swirly pattern. And I'll show you a map in a moment. This is what we call the jet stream. You ever heard of the jet stream?
Yeah, I heard of it.
Okay. The jet stream is this stream of very fast moving air, like up to 200 miles an hour at times, that moves from this west to east. Now what this does is this changes all the time because the weather is always changing. These air currents are always kind of morphing and changing. And so this can change at different times of the year, and it will actually drive our weather as well as the prevailing westerlies does.
So is that like the main flying route for like jets and stuff?
If you're going from the west to the east, if you can get in the jet stream, absolutely. Because if they get into this fast-moving speed of wind, they don't have to use as much fuel and can go faster.
Oh. So it moves to the west to east
Yes.
because the
the
lower pressure
prevailing
air
westerlies
is
take
going
over.
that way?
Yes.
Yeah, okay.
Prevailing westerlies take over. Yeah, absolutely. So what he's saying is since the low-pressure air is going this way, the high-pressure air is chasing it and trying to catch up with it, so it moves this way as well, and it creates that fast-moving stream.
So wait, then why doesn't the other one,
The polar.
easterlies, go west?
Because it's moving east because of the way the convection current forms.
Then the
But just along this line, it'll move west. This air up here still moves east, but the air right along this line will move west, trying to catch up with this low-pressure air that you're talking about.
There was a story that my dad told me that like there were some guys they were coming back from someplace in a plane
Mm-hmm.
and their I don't know stuff to tell them where to land. It said that like could land now because they were going right over the satellite like to land.
Mm-hmm.
They thought that could be right because they were like that's like an hour ahead of schedule.
Because they got in the jet stream and they got there
Yeah,
really fast.
but they passed it and they didn't.
Yeah, and that happens a lot. And these pilots, they know this, and they will actually get in there intentionally to move faster, and your flights can move very quickly if you are able to get in the jet stream. The jet stream is interesting because it does change on an almost daily basis, and so you end up never exactly knowing where it is, so you have to kind of find it. Right? And they do have instruments that they can find it with, but we don't know on a day-to-day basis. Does this make sense? Okay, and obviously, this area down here at 30 degrees south, these mid-latitudes will also be horse latitudes. Okay, everything that happens here is mirrored down here. Questions? You can stop thinking.